Okay, I have no idea if this will be helpful or not, but what I've set up here is essentially a batting cage for slopes of lines, equations of lines that are both parallel and perpendicular through another point. And I just kind of want to explain what this is doing. So, kind of at the most basic beginning thing, A and B are two lines that you can move wherever you want, and it doesn't matter where they end up. So, for example, if I put B right here and it's nice if you let it pick some integer values. So if B is at 6, 7, right, X is 6 and Y is 7, and A is at 3, 6, one of the things you can do is you can calculate the slope of that line. So 7 minus 6 is 1, divided by 6 minus 3 is 3. And if you look over here, this line that goes through the two blue dots will always be shown as this top line, right? So the equation of this line is y equals 1/3 x plus 5. The other thing you can see is that the y-intercept is at 5. Now, what I recommend is that on your own scratch paper, you just write down the points and you come up with the equation of that line completely on your own. Then you can come over here and peek and see, oh, look at that's what it should be. In fact, if you don't trust yourself, you can slide this over a little bit and then hide it or show it. This is yeah, so you can just kind of like, oh, there it is. Um, and if for some reason this page gets mixed up, if you just refresh it and open it up, it'll start and it'll look pretty much just like this when you get there. The other kind of question I might ask you, besides, hey, here's 2 points, what's the slope, that goes through them? I could say, hey, what's the equation of the line that goes through them, right? And sometimes you can get the y-intercept quite nicely by, it's just kind of a nice, these are nice integer numbers. But if you look at this, that's still a nice number, isn't it? Boy, there's a nice y-intercept too. Let's come. Where's a y-intercept that's not nice? That's not nice. There we go. So you can see now the equation of this line that again goes through the two blue dots is y equals negative 1/3 x plus 16 thirds. So that y-intercept is at 16 thirds. Now again, if you go somewhere else and you're just on paper, you just start with these points, you should be able to verify that that's what the slope is. You should be able to plug that slope in and one of the 2 points to get exactly this is the y-intercept. Another thing that you have access to is there's this extra point C. So let's say that I say point C is at 1, 2. I could ask you this question. What's the equation of a line that goes through point C and is perpendicular to the line that goes through AB? So you can see I'm talking about this red dashed line. What's the equation of that line? Well, I know I know in order to answer that question, I need to know the slope of the line through AB, and I can see the slope of that is down 1 over 1, 2, 3. So this line through C has to have a slope of the opposite reciprocal of that. So instead of going down 1 over 3, it should go up 3, 1, 2, 3, and then to the right 1. So you can see up 1, 2, 3 to the right 1. So the other thing that has to be true is it has to have this slope of positive 3. But then I have to figure out what the y-intercept is, and I would use the xy from this point C and that slope to calculate it. Now again, the answers are all over here, right? This red dashed line, that's the perpendicular one, is y equals 3x minus 1. There's a parallel line down here, that's the green one. It is parallel to the line through AB, and it is also going through the point 1, 2. So if you understand this properly, what I've set up is a way for you to, if you will, you can hide this off to the side. And you can say, look, I'm going to pick any 2 points I want. Like I might put B here, and I'll put A right here. And I do recommend using integers, right? Using nice numbers. And then I could be like, okay, what's the slope of the line through AB? Okay, if I answer that, I would also know the slope of the line through the green dashed one, right? Because it's parallel, so they have the same slope. I could also say, what's the slope of the line through C? Well, if I know the slope of the line through AB, I know the opposite reciprocal is the slope through C. I could ask, what's the equation of the line that goes through AB? You should be able to come up with not only the slope, but also the y-intercept. Then I can also say, what's the equation of the line through point C that's parallel to AB. So now because I said parallel, you're going to use the exact same slope that you are from AB, but you're going to use this C points X and Y, and when you do that, it's going to help you figure out what the Y-intercept is for the green line. And then I could also ask you, okay, what's the equation of a line that's perpendicular to the line AB, but it goes through point C. So again, it's a perfect place where you can go and play with this. It looks like that's going through 4. But then once you answer, you decide which of those questions you want to answer, right? You can just pull it over and you can see that, the equation of the original line is y equals 1/2 x plus 5 halves. The parallel one is y equals 1/2 x plus 3 halves. And the perpendicular one has this equation of y equals negative 2x plus 4. So this will be here. It's in the notebook. Feel free to open it up anytime. And these these equations get very, like, those are very intimidating looking fractions when you do it like that. But try and give yourself some integers that are relatively easy for you to deal with, because those decimal approximations would be, I don't know. Anyways, that's it. I hope you find this helpful, and I hope you spend a lot of time in the batting cage.